Hi, this is your math teacher, Sir Win. But before that, let's have an activity. I will give you 10 items to answer if you really understand our previous lesson. Let's start.
Read each item carefully and choose the letter of the correct answer. Number 1. Which of the following shows the angles of triangle SET in order from smallest to largest? A. Angle E, angle S, and angle T. B. Angle E, angle T, and angle S. C. Angle S, angle E, and angle T. And D. Angle S, angle T, and angle E. Time's up. The answer is letter C. Next, number 2. In triangle FIT, line segment FT is greater than line segment TI. Which statement must always be true? A. The degree measure of angle F is greater than the degree measure of angle T. B. The degree measure of angle F is greater than the degree measure of angle I. C. The degree measure of angle T is greater than the degree measure of angle I. And D. The degree measure of angle I is greater than the degree measure of angle F. Time's up. The answer is letter D. Next, number 3. Which shows the sides of triangle FLY in order from longest to shortest? A. Line segment LY, line segment FL, and line segment FY. B. Line segment FY, line segment FL, and line segment LY. C. Line segment LY, line segment FY, and line segment FL. And letter D. Line segment FY, line segment LY, and line segment FL. Time's up. The answer is letter B. Next, number 4. Which sides of triangle BIG are the longest and shortest if the degree measure of angle B is equal to 35 degrees and the degree measure of angle I is equal to 95 degrees? A. The longest is line segment IG and the shortest is line segment BG. B. The longest is line segment IB and the shortest is line segment IG. C. The longest is line segment BG and the shortest is line segment IG. And D. The longest is line segment IG and the shortest is line segment IB. Time's up. The answer is letter C. Next, let's proceed for number 5. What is the shortest side of triangle SUN if the measures of the degree measure of angle S is equal to 12x minus 9 degrees, the degree measure of angle U is equal to 62 minus 3x degrees, and the degree measure of angle N is equal to 16x plus 2 degrees? A. Line segment SN. B. Line segment US. C. Line segment UN. And D. Cannot be determined. Time's up. The answer is letter A. Next, which of the following statements is true about exterior angle inequality theorem? A. The measure of an exterior angle of a triangle is greater than the measure of its interior angles. B. The measure of an exterior angle of a triangle is greater than the measure of its remote interior angles. C. The measure of an exterior angle of a triangle is less than the measure of its remote interior angles. And D. the measure of an exterior angle of a triangle is less than the measure of its interior angles. Time's up. The answer is letter B. Next, let's proceed for number 7. Refer to the figure below or on the slide and identify which statement is true. A. Line segment NC plus line segment CR is equal to line segment NR. B. Line segment NR plus line segment CR is greater than line segment NC. C. Line segment CR is equal to line segment NC plus line segment NR. And D. Line segment NC is greater than line segment NR plus line segment CR. Time's up. The answer is letter B. Next, the following sets of numbers are the lengths of the sides of the triangle except A. 7, 5, and 4, B. 9, 6, and 5, C. 11, 12, and 29, and D. 25, 32, and 56. Time's up. The answer is letter C. Next, let's proceed for our next item. What is the range of possible measure of a triangle with sides 29 and 50? A. 21 is less than x is less than 79. B. 21 is greater than x and greater than 79. C. 71 is less than x and less than 21. And D. 71 is greater than x and greater than 21. Time's up. The answer is letter A. Next, last item. Using the figure on the right, which angle is less than angle 4? A. Angle 7. B. Angle 6, C. Angle 3, and D. Angle 2. Time's up. The answer is letter D. I hope you enjoy our activity.
Our lesson for today is all about illustrating an experiment, outcome, sample space, and events. After going through this lesson, you are expected to first, illustrate an experiment, outcome, sample space, and event. Second, realize the importance of an experiment, outcome, sample space, and event in real life. Let's proceed. Raffle draws are very common. Fanfare in schools, communities, malls, and other fundraising events. You will find it interesting and exciting to win the prizes. But there are some instances to feel awful because of small chances to get the prize. This applies probability. In the real world, it is difficult to predict with total certainty if an event will happen. The best we can do is stating how likely these events may happen using the idea of probability. This is a spinner with 3 equal parts, labeled red, blue, and yellow. How many possible outcomes are there and what are the possible outcomes? What are the special terms related to it that will lead to understanding probability? Let us look and study the definitions to help us answer the problem. To solve this problem, let us answer the following questions. Number 1, what do you call to the situation that leads to anticipated results? Number 2, how will you get the possible outcomes in the event? Number 3, how many sample spaces will you get on the said activity or event? And number 4, how will you find or determine the outcomes, sample space using the experiments? Of course, to answer all those questions, you should know first the definition of sample space, events, outcome, and experiments. The activity, which is spinning a wheel, is an example of experiment. Experiment is an activity such as rolling a die, tossing or flipping a coin, or picking a card from standard deck of cards, without looking, which could be repeated over and over again, which will have a well-defined result. The result of the experiment is called an outcome, and the set of possible outcomes are called sample space, and the subset of the sample space is called the event. In spinning a wheel, the results of getting a red, a blue, or a yellow are the 3 possible outcomes. Hence, the sample space of the experiment is the set red, blue, and yellow. Let us solve more problems in determining the possible outcomes in the experiment for better understanding. Here are some examples of experiments.
For our first experiment, if you roll a die, how many possible outcome and sample space will you get in the event? Let's list down some possible events from the experiment. For our solution, in rolling a die, the result of getting a 1, a 2, a 3, a 4, a 5, or a 6 are the 6 possible outcomes. Hence, the sample space of the experiment in the set are 1, 2, 3, 4, 5, and 6. And here are the possible events from this experiment. The dice turned up at odd number. We have 1, 3, and 5. Number turned up is a special number, which is 1. Number turned up is a prime. We have 2, 3, and 5. Number turned up is a multiple of 3. We have 3 and 6. Number turned up is even. We have 2, 4, and 6. For our second experiment, you will draw a marble from a jar containing 4 marbles of red, blue, green, and yellow. How many possible outcomes, sample space in the event? What are some events can be possibly drawn? For our solution, in drawing marbles, the result of getting a red, a blue, a green, or a yellow are 4 possible outcomes. The sample space will be red, blue, green, and yellow. And here are some possible events for this experiment. Drawn marble is yellow. The result is yellow. Drawn marble is not blue. We have red, green, and yellow. Drawn marble is red or green. The result is red and green. Drawn marble is the primary color. So we have red, blue, and yellow. And drawn marble is not primary color. The result is green. That is our second experiment. For our third experiment, in tossing a coin, how many possible outcome and a sample space can you get in the experiment? What are some events can be possibly tossed? For our solution, in tossing a coin, the results of getting a head or a tail are 2 possible outcomes. Next, hence, the sample space of the experiment in the set are head or tail, or H or T. And here are some events in a tossing a coin. Tossing a coin, is head. The result is head. Tossing a coin is not a tail. The result is head. Tossing a coin is tail. The result is tail. And for our last possible event, tossing a coin is head or a tail, and the result is head or tail. That is our third experiment. Let's proceed for our fourth experiment. A pair of dice, which is a black die and a white die, is tossed. List all the elements in the following events. The first A, we have the number shown on 1 is 3. B, the sum is 7. C, a number is less than 3 is shown on each of the dice. And D, a number greater than 4 is shown on each of the dice. For our solution, the symbol 1 and 4 is tossing a black die, and a white die means 1 dot on the black die and 4 dots in the white die. Thus, 6 and 5 means there are 6 dots on the black die and 5 dots in the white die. Here are the sample space. We have 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6, 3 and 1, 3 and 2, 3 and 3, 3 and 4, 3 and 5, 3 and 6, 4 and 1, 4 and 2, 4 and 3, 4 and 4, 4 and 5, and 4 and 6. Next, we have 5 and 1, 5 and 2, 5 and 3, 5 and 4, 5 and 5, and 5 and 6. Next, we have 6 and 1, 6 and 2, 6 and 3, 6 and 4, 6 and 5, and 6 and 6. These are our sample space. Now, for letter A, which is the number shown on 1 is 3. The elements of the event A that the number shown on one of the dice is 3 is 1 and 3, 2 and 3, 3 and 3, 4 and 3, 5 and 3, 6 and 3, 3 and 1, 3 and 2, 3 and 4, 3 and 5, and 3 and 6. Now for our letter B, which is the sum is 7, the elements of the event B that the sum of the two number is 7 is 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, and 6 and 1. For our letter C, a number is less than 3 is shown on each of the dice. The elements of the event C that a number less than 3 is shown on each of the dice is 1 and 1, 1 and 2, 2 and 1, and 2 and 2. And for our letter D, a number greater than 4 is shown on each of the dice. The elements of the event D that a number greater than 4 is shown on each of the dice is 4 and 4, 4 and 5, 4 and 6, 5 and 4, 5 and 5, 5 and 6, 6 and 4, 6 and 5, and 6 and 6.
Now, what if there are a pair of dice tossed? What will be the outcomes in the event and the outcome in sample space? On this different experiment, it is clearly shown that every outcome in the event, or E, is also an outcome in sample space, or S. Remember, events are subsets and subsets are events. So, event, or E, is a subset of the sample space. In symbol, it is like this.
Now, let's proceed to the union of two events. The union of two events is all outcomes in either or both events. The union of two events, or A sub 1 and B sub 2, is denoted by A sub 1 is the union of B sub 2. Thus, the event A sub 1 is the union of B sub 2, read as A sub 1 union B sub 2 comprises the set of outcomes of either of both A and B. For example, A sub 1 is equal to 1, 2, and 3, and B sub 2 is equal to 3, 4, and 5. So A sub 1 is union of B sub 2. So we have now 1, 2, 3, 4, and 5. Using the Venn diagram on the left side, it shows the union of the events A sub 1 and B sub 2 in the experiment. Now, let's proceed to the intersection of two events. The intersection of two events is only those outcomes common in both. The intersection of two events A sub 1 and B sub 2 is denoted by A sub 1 intersection B sub 2, comprises the set of outcomes common to A sub 1 and B sub 2. So, the intersection of A sub 1 and B sub 2 is 3. Using the Venn diagram, it shows the intersection of the events A sub 1 and B sub 2 in the experiment, which is 3. Now, let's proceed to the complement of an event. The complement of an event is the set of elements of the sample space, which are S, that are not in E or event. The complement of event is denoted by E apostrophe. Thus, the event E, read as complement of E, or E prime, is the set comprising all the outcomes in the sample space that are not in event. So, in our die experiment, the E prime here, or the complement of E here, is 4, 5, and 6. Using the Venn diagram on the right side, it shows the complement of events in the experiment, which are 4, 5, and 6.
In an experiment, the probability of an event is the likelihood of that event occurring. Probability is a value between 0 and 1. If P of E represents the probability of an event, or E, then a listing of all the outcomes of an experiment is called the sample space, or S, of the experiment, and N of S represents the number of outcomes in the sample space. If N of E represents the number of outcomes in event, then N of E sub 1 represents the number of outcomes in the first event, and N of E sub 2 represents the number of outcomes in the second event. Now, that is our lesson for today, which is illustrating an experiment, outcome, sample space, and events. Thank you for watching.